Hi again, everybody. This is Joseph, and today's discussion is about the schematics for the PCM, which is a powertrain control module for GMs, Chevys. And as you can see, I took the liberty of overlapping one page to another page to another page to another page. And this is the PCM. You can have 200 connections, pins to it. And therefore, I traced the lines, but obviously we're not going to go over every single line. This is just an outline to see what is encountered with the PCM and the lines that it commands, inputs and outputs. But when you read a schematic, as I said before, and I want to thank Scanner Danner for his comment. I want to thank Jim, the car guy, for his comments and subscriptions. Subscribing. Thanks a lot. I watch your videos, and like I said, you are automotive gods in YouTube. Thanks for watching. Anyway, like we said, when you start looking for something, especially troubleshooting, when you have a schematic with so many components and so many lines, you're going to go first to that component. So in other words, let's say I look for fuel injectors. I think I have a problem with a fuel injector. I'm not going to concentrate on the sensors right now. I'm not going to concentrate on ignition systems, distributor, the computer. I might have to go back to the computer after I trace it to that part. As we said, main components. When you trace and when you analyze and when you troubleshoot, you pay attention to main components. So I look for fuel injectors. Right here, I found the area of fuel injectors. Now, as I said before, fuel injectors need a positive and they need a ground. Now, the positive is usually a common bus line. As you can see, the pink wire, pink, 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 over here, they go to this common line, and that common line has to go to a B+. So if we trace this one, if we trace this pair, this pair, this pair, they all go to right here, the ECM fuse, which eventually obviously goes to the battery. So therefore, how much can you withdraw? 15 amps. So we have the B+. We need a B+. We just said that. How many cylinders? There are 6 cylinders, so we expect to see 6 fuel injectors for a V6. Obviously, if there would be 8, we would have 8 almost in parallel. Almost in parallel. This part is connected together. However, the bottom goes to the computer. So it's not really in parallel fully. Parallel means on the top, you're connected together, and on the bottom. The computer will give it a ground. You need 2 things, 2 variables for a relay, for a fuel injector, and that is a B+ and a ground. How you give that ground could be a physical ground on the chassis, or it could be a ground given by a computer. In this case, we have something called pulse width modulation. Pulse width modulation is a pulse, and it's been around for over 20 years, actually, with switching power supplies that I did over 20 years ago. Anyway, this pulse, as I showed you over here, this is the pulse. We'll give it 0 volts or ground to activate or open up the fuel injector. What will that do? That will allow fuel to go into the cylinder, each cylinder. Therefore, we have to open it first. How do we open it? The computer decides when to open it and how long to open it, thus commanding how much fuel goes into each cylinder. So therefore, you're going to see a negative ground, a negative pulse. How long this is, from here to here, is the time period. So in this example, if you're going from here to here, let's say 3 milliseconds. If you expand it, you'll be more than 3 milliseconds because you want more fuel. What is that determined on? It's determined on load conditions. The computer looks at the load conditions, meaning how long the TPS sensor, the TPS is open, when you hold the pedal, vacuum, everything is taken into consideration by sensors on the TPS and other sensors. Those are inputs. They tell the computer, okay, let's give it a pulse for 3 milliseconds. If we need more, it will expand it. If we need less fuel, it will compress the pulse. There's something called the duty cycle pulse width modulation. Duty cycle means how long this is from here to here as a percentage. So the frequency doesn't change, but the percentage might change. And if you have a fluke meter, as you do over here, if you put on AC or DC, if you have this one and then there's another one also, an upgraded one for fluke. If you go to, I'll take it off. Now it's reading AC millivolts. 400 millivolts is the scale. For each one is 100, 200, 300, 400 millivolts. Now, the reason it flickers is because it reads things, measurements, any measurement that's in the air. So sometimes your lights will give off frequencies and small voltage amounts. So you could disregard that. The only thing is you look at AC millivolts and 400 millivolts. This is auto. So that means it will automatically go to the range to give you the best decimal reading. So in other words, if I go to Hertz, Hertz is associated with frequency. So if I press Hertz, I can measure frequency. If I go one more time, I can measure percentage. That percentage will give me the duty cycle, how long this is on. But remember, take into consideration that even though it's going to tell you how long, 50%, 40%, 20% duty cycle, I always like to see on the scope the actual pulses when this computer is turning it on. Because I know I'm going to see glitches. Sometimes you have glitches up here. Overshoots, undershoots, that's okay. I'm looking for the pulse width. And I want to make sure that the computer is giving it a command. Now, we spoke about one thing, inputs and outputs. If we go and you look at the red lines and we go and we trace it back to here, we go to the pins. These are the pin numbers. As I said, there could be 200 pins or more. Injector 1, injector 3. So 37, 38, those are associated with injector 1, injector 3. They will give it a pulse to turn it on or off, depending how long they want to turn it on and off based on sensor conditions. Like I said, TPS, vacuum, other things, map sensors. This will command, let's say these are the outputs. If the computer commands something, you can refer to that as the output to the computer. If the computer is getting information from the sensors, it is an input. You will not see arrows like I did over here. You will not see input showing input going in or going out. Occasionally you might have some schematics. But that's where you have to be a good tech and understand what's going on if you are involved in electronics, automotive. So therefore, when you see this, these are outputs controlled by this PCM. Injector 1, injector 2. Of course, there's 6 of them, right? So therefore, injector 4. So therefore, the first thing that the PCM needs, 12 volts. It needs 12 volts. When I used to work on PCMs, actually an instrument cluster of panels, a lot of the times from vibration, they have chips in them and the pins have to be reflowed. They have to be resoldered because the pins come off. You're talking about surface mount, sometimes 100, 200 pins. And they come off. They have to be reflowed. Also, on the instrument cluster panel, they have microprocessors, memory. Also, they have to be reflowed. Well, vibration. You hit a bump, that's it. So therefore, what's in here as a technician for automotive, I'm not interested really what's in here. All I'm interested in, this is a ground that goes right to the ground. The computer can give it a ground. It can give it a ground. It could go a low reference by giving it a ground. So therefore, when we look at sensors, and here's a sample to take into consideration. A knock sensor. There are two wires over here. Over here, heated oxygen sensor, and it tells you bank 2, sender 1. And Mitchell is good. And I agree with the other technicians who say they give you the location of the sensor. A description where it is. So it makes it easier for you to find it. So therefore, knock sensor is an input. These two are inputs. Heat oxygen sensor is an input. A closed loop. Tells you how much oxygen is coming out. And therefore, the air-fuel ratio, the air-fuel ratio can be adjusted. Let me try to adjust the picture a little better. Let me try to adjust it. So therefore, now, again, outputs can be solenoids. Automatic transmission have solenoids. So these are the outputs. The computer will command these on and off. Inputs, again, inputs will be engine coolant temperature sensor. And how many wires are here? 1 and 2. It's called a thermistor, where with heat, the resistance of this changes, usually goes down. It's called a negative coefficient. Sometimes it's called a positive coefficient, where the resistance goes up, but most of the time we're talking about negative coefficient, where as it gets heated, the resistance goes down, and the voltage will go down from 5 volts reference. So therefore, there are 2 wires over here, black and yellow. And if you want to know the location, it's over here. However, this one over here, throttle position sensor, how many wires are there? 3. There are 3 wires. This will be 5 volts. This will be one going from 12 volts. This will be the one, the middle one will give you the control signal or the information of the position of the plate when you open it. It's called a pot. This one's called the wiper, actually. So this voltage will change. The middle one will change. The other one will be 12 volts, so ground, steady, and this will change. But these are inputs. Sensors are inputs. Okay? It's like I say, when you go to a doctor, he asks you the symptoms. You tell him coughing and all these things. Therefore, those are input to the doctor. Those input information to the doctor. What he tells you to do is the output. To command you to do something, to take medication, whatever. That's the best way that you can understand these things. So therefore, as I said before, let's say I'm looking for, and now the light got different, so it might be a little hard to look at it. But anyway, so if you look for, let's say I'm concerned about the fuel pump issue, right? Fuel pressure is low, and I'm concerned maybe it's a fuel problem. Where am I going to be concerned with? I'm not going to be concerned with yet the PCM. I'm not going to be concerned with sensors, TPS. I'm going to be concerned with the fuel pump, the motor, the pump. Now, you have pumps, your motors that go in one direction. You have motors that go in both directions. That will go in bidirectional. So in this, let's say over here you have idle air control. Let's just see you have coils here, dictated it to go in which direction. This motor can go both directions. In your power seats, Power mirrors, you have motors. If anything is power, it's a motor, but it goes in different directions. When you want the seat to go forward, it goes in one direction. When you want the seat to go back, it goes in a different direction. When you want the window and power windows to go down, motor goes in one direction. When you want it to go up, the motor goes in the other direction, bidirectional. So, in this case, what are we dealing with? Let's say the fuel pump. Now, I didn't color this one in, and I apologize again for the lighting because it changed. But anyway, we know one thing. The pump needs, again, pump needs a ground. It could be a physical ground. And it needs a B+. However, there are relays involved. Computer controls the relays. Computer controls relays, sometimes giving the relay a ground, sometimes giving it a B+. Now the light got better. Anyway, as I was referring to before, these are sensors. These are sensors. These are outputs. These are solenoids. When the computer commands it, it's an output. These heated oxygen sensors, as you can see how many wires there are. 1, 2, 3, 4 for each one. And the location. This is the heater over here. Therefore, these are all inputs. Why? Sensors are inputs. They're telling the present condition to the computer what's going on, so that the computer can control the air-fuel mixture and try to get it as close as possible to the stoichiometric ratio of 14.7 parts air to 1 part fuel to give you good emissions. Now, again, let's take our example. The AC and also the AC generator is controlled by the computer. Everything controlled by the computer. But you have something called OBD2 and you have something called CAN, where all these things, all these modules and control units talk to each other, almost like in a star configuration or gateway configuration, where one can talk to the other if there's a problem. Therefore, there's serial data and there's inputs, outputs. It is the generator is controlled also. The output is controlled by the computer. The computer controls everything. Controls the relay, turn on the starter, some makes and models. It controls everything. Based on, obviously, if the crankshaft sensor and the camshaft sensor gives it the signals, it knows that the engine is cranking. If not, no fuel, no spark. Anyway, again, we're involved now in the fuel pump. We think there's an issue with the fuel pump after we measured low fuel pressure. So anyway, we're going to go over here. We're going to go see the fuel pump is right here. That symbol is for fuel pump. Of course, where it is, on top of fuel tank. And of course, when do you have to replace it? When it's full of fuel. When you need 2 people to take it down. Anyway, we go over here. If we trace it, if we have a ground, even though it's a physical ground, what are we looking for? We expect the other side to be B+ somehow. Could be through a relay, could be through a fuse, but we have to find somehow that this side goes to 12 volts. Let's see if that's true. I didn't highlight it, but here's the where it goes to. And it goes to right here, this part of the relay. When this relay is closed, guess where it's going to? B+. Through this fuse. So therefore, we're getting the B+ on the condition of that this relay has been activated. So therefore, the B+ goes through here, comes back this line. Now, the fuel pump relay. We need 2 things again for a relay. We need a B+, we need a ground. So therefore, now again the lighting changed from the sun. So anyway, this ground over here is one side of the coil, the relay. I expect the other side to be B+, correct? If one side is, even though it's a physical ground, it says right rear of cylinder head. Even though it's a physical ground, if one side is ground, I expect the other one to be B+. Because you can't have both sides grounds. You can't have both sides B+. This is ground. Let's trace it and see if it comes to a B+. So I go over here, I go over here, I go over here, and anyway, when I traced it, it came out to, if you can see it, fuel pump relay. So it's like it's giving it a B+. The computer's going to give it a B+ to turn this on, activate this, create a magnetic field for this, to energize this. This contact will come down. The armature will be energized. It'll come down, close this circuit, and give it a B+. So the computer controls the fuel pump relay. Therefore, we need this connection to be intact to the computer. If this is not intact, fuel pump relay will not be activated. No 12 volts. Again, in these PCMs, there are bad soldering. As I said, pins comes off. They have to be reflowed, but we're not dealing with that. We're just dealing with, is it the PCM, is it not the PCM? Always take that into consideration. Anyway, like I said, I apologize for the lighting. It changed, I guess, from the sunlight. But anyway, as you can see, it's difficult, electronics, but try to focus on what you're directly dealing with. If I'm looking for fuel injectors, I'm dealing with this part of the schematic. If I'm looking for engine coolant temperature, I'm dealing with this one, and I'm tracing it back. I'm not dealing with TPS sensor or anything like that. If I'm looking for a TPS sensor, I'm dealing with this. I start with this. This is the main component, and I trace it back to where it's going. Now, remember one thing. In these, I overlap them together. They connect together. If you look, yellow 29 goes to yellow 29. However, the numbers might change. So instead of this 29, might be another one. Might be a different number. So keep